I am sharing my screen with you, so can you confirm if you can see my screen? Let me change a window. Yeah, I am starting. Maybe you can see my screen. Yeah, as I said earlier, I am Hassan Al-Banna Himel, currently studying in Bragg University. Uh, Welcome in Linear Algebra for AI and ML Day-4 with Hassan Al-Banna Himel. This session is supported by Global AI Community, Dev Changemakers, NSDC Bracket Chapter, and TensorFlow User Group Bangladesh. Now let's start. Let's see what we will learn today. In today's session, we will learn about matrix decomposition. Let's look something about matrix decomposition, or what is matrix decomposition. Matrix decomposition breaks down a matrix. In our previous day 1, 2, and 3, in those 3 days we learned about the basics of matrix and how to do matrix addition, matrix multiplication, and more on. And we learned about what types of matrices are available there now, and then we learned about the differentiation or derivatives of the matrices. Now, in today's session, we will be covering matrix decomposition. What is matrix decomposition? Matrix decomposition breaks down a matrix into simpler components. If I have a complex matrix, let's assume I have a matrix of A to P. It is a infinite matrix. We don't know what is the end. So for to clarify ourselves or to make it easier, we do matrix decomposition. It helps us to easier manipulation or analysis. What helps this for? It helps us in solving equations, understanding data, or optimizing the computations. Now, what are the types of matrix decomposition? Let me add something. If you have any questions, you can raise your hand. I will give you the floor and then you can ask me the questions. Yeah. Now, what is or how many types of matrix decomposition are there available? There are 5 kinds of matrix decomposition available. In this session we will cover the LU decomposition, the PLU decomposition, and we will see some sort of QR decomposition. In the next session we will be covering the QR decomposition in more proper way, and there are 2 more decomposition, that is called singular value decomposition or so-called SVD, and finally eigenvalue decomposition. We will covering the last 2 in the next session. We will be covering today LU decomposition, PLU decomposition, and QR decomposition. Now let's move to our next slide. What is LU decomposition? Sorry for that. By definition, LU decomposition or LU factorization splits a matrix into lower and upper matrices. If we look at a matrix, let's assume A is a matrix. It is a 4 by 4 matrix. It occurs. It has 16 elements. 1 2 3 4 5 6 7 8 9. Again 1 2 3 4 5 6 7. Yeah, as far we know, it is a 4 by 4 matrix, and here this is called the lower triangular matrix, and this part is called the upper triangular matrix. And in this part we will be seen doing how to decompose it with LU, I mean the lower triangular matrix, and with the help of upper triangular matrix we will simplify this matrix equation. It aids in solving the linear systems, linear inverses, and determinants efficiently. Now let's look at a problem. Here let's assume we have a matrix. Let's assume it as A. I am changing my screen for better view. Here let's continue how we can do the LU decomposition. If we look at LU decomposition, the L stands for lower triangular matrix and the U stands for upper triangular matrix. We saw in the slide that what is a lower triangular matrix and what is a upper triangular matrix. Now let's do this math. Here we can see it is a 4 by 4 matrix. Now to do a decomposition we need a identity matrix. We all know what is a identity matrix. In an identity matrix the trace is only 1 and the other values will be 0. For this the identity matrix will be like, let's assume the identity matrix as I. The identity matrix will be 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. This will be the identity matrix for this part of decomposition. Now we can see that in the next line we will multiply our identity matrix with our given matrix. Now let's write the identity matrix. 1 0 0 0 0 1 0 0 0 0 1 0 and finally our last row 0 0 0 1. Now we will multiply this matrix with our given matrix. We have a matrix given 4 by 4, 2 4 3 5 minus 4 minus 7 minus 5 minus 8 6 8 2 9, and in our final row we have 4 9 minus 2 14. Now in this decomposition our final goal will be one side will get the lower triangular matrix and other side will be our upper triangular matrix. For this math we will do this side for our lower triangular matrix and this side will become our upper triangular matrix. For this we will convert our right side matrix. In the lower matrix the other elements will be 0, like the 2 1 element, the 3 1 element, the 3 2 element, and finally the 4 1 4 2 and 42 element will be 0. And in this part, in the left side, our 1 2 1 3 1 4, our 2 3 2 4, and 3 3 and 3 4 will be 0. Now, to make this side 0 and this side visible with digits, we will multiply our first numerical value, or we will call this pivot. This will help us to make this column 0. Now let's watch how we can make this column 0. If I multiply the second row with, sorry for that, if I multiply -2 with our first row, then we will make this 0. Now let's see. If I multiply this with -2 and our first value, what will we get? And the digits will be present here equivalently. We got 1 0 0 0. Here we got -2, we will be given -2 and 1 0 0. Now let's calculate here. The first row will be same, 2 4 3 5, and now it came to our second row. When we calculate, we will get 0 1 1 2. Now our second row has become 0. Now it is turn for our third row. How can we make our third row 0? If we multiply this with 3, we can make it 0. So to subtract, we will subtract our row 3 with 3 multiplied by our row 1. Now we will get, as we said before, we will get a value which will be 3. And now let's calculate for the third row. We will get 0 -4. For clarification, this is the other line. This one is our first line and this is the second line. Yeah, so 0 -4 -7 and -6. And then for the last row, we will multiply with 1. We subtract our fourth row and multiply our first row with 1, and we will finally get 0 1 -8 and 4, and the other values will be remain same, 0 1 0. Here we multiplied it with 1. My bad, we are multiplying this 2 multiplied by 2, sorry for that. We will get 2, and here 0 0 and 1. Now we got our first row 0 except our 1 1 element. Now let's move on to our second row. Now in this part, our pivot will be 1. For this, we will be doing, let's at first write our given components: 1 -2 3 2. Now we are doing it for the second column, so let's give the last 2 do not give it, or and the third column will be 0 0 1 0, and fourth column will be 0 0 0 1. Now for this part we will be completing math with this part. Our this part is done. Now we're doing with this part. Now let's to solve the third row. We will be subtracting third row with -4 multiplied by 2, our second row. While we do this, our this part will be 0, and this will help to give us a lower triangular matrix. Now let's see for while we do this, we will get 2 4 3 5, and here we will get in the second row 0 1 1 2, and while we have done the calculation, we will put this value in our the first matrix, and while we done the calculation, we will get 0 0 -3 and 2. For our last row, now we need to make this value 0 or null. So while we do this, we need to multiply our second row with 1 and subtract it with our fourth row. Now while we do this, we got our last value. This will be given here, and after the calculation we will get 0 0 -9 and 2. Here we can see almost on the left side of the matrix we almost got the lower triangular matrix, and in the right side we can see we almost got the upper triangular matrix. What is causing the difference? Here we will do with this one value and this value. Now let's do it for our final part, or row 4. To making the row 4 here the 9 0, we will multiply our third row with 3. While doing this, we will get a -9, and after a +9, after subtracting with this, we will get 0. So for our final value, we are getting 0 1 -4 1, and on the third column we get 0 0 1 3, and the rest of the last column. And after the calculation, we will get 2 4 3 5 0 1 1 2 0 0 -3 2, and finally our last row 0 0 -9 and 2. Here we can see our this part has become the lower triangular matrix, and in this part this part has become the upper triangular matrix. So yeah, this part is called the L, or the lower triangular matrix, and this part is called U, or upper triangular matrix. Now here comes the twist. when we will multiply our L or the left part and with our right part, we will get the matrix A, or our given matrix here, the 4 by 4, that 2 4 3 5 minus 4 minus 7 minus 5 minus 8 6 8 2 9 4 9 minus 2 and 14. When we will multiply this part with this part, we will again get the matrix A. Yeah, this was the LU decomposition. If anyone have any question, you can ask. Does anyone have any questions? You can raise your hand. Peter, Nishat, Nafil, if you guys have any question, you can raise your hand. Yeah. So now let's move on to our next part. So yeah, we understood the LU decomposition. It is completed for us. Now let's move on to the PLU decomposition. At first, let's divide what does P means, what does the L means, and what does the U means. PLU decomposition is kind of the extension of LU decomposition. Here, the P is a permutation matrix, the L is, as said before, our lower triangular matrix, and for square matrix in this decomposition, the U will remain the upper triangular matrix, but while we're doing our next example, it will be one row echelon form. Now let's look at the definition. What is the definition of PLU decomposition? PLU decomposition is an extension of LU decomposition, as I said before, that includes our row permutations, allowing for better numerical stability. In the next math, we will see that the our numerical stability will be not evenly available, so we need to do the row permutations, which will allow us to do the better numerical stability. It will break a matrix into a permutation matrix, a lower triangular matrix, and an upper triangular matrix, as I said before. In the previous example, we have seen that we got a lower triangular matrix and a upper triangular matrix, but in this decomposition we will get three forms. We will get a permutation matrix, a lower triangular matrix, and an upper triangular matrix. Now let's look into our problem or today's example. Here we have a 5 column and 4 row matrix. Now let's assume it as A matrix, as we do always. Now let's go to our OneNote again. Yeah, now let's get here. We can see that it is not a square matrix, and we know for LU decomposition we need to do it with identity matrix, and we all know that identity matrices are square matrices. Now let's do this. We will do this with a 4 by 4 matrix, and which will be a identity matrix. Now let's assume P identity matrix, which will have 1 0 0 0 0 1 0 0 0 0 1 0 and finally 0 0 0 1. As we can see in this problem, our first pivot or our first digit isn't 0, it isn't 1, it is a 0. So we can't multiply something that will help us to make it 0. So we will do something which is called row transformation. Here in if we look in the identity matrix, to clarify it, we will change our first row with our second row. We will clarify it with 1 2 2. That means our first row will become our second row and our second row will become our first row, which will help us to do the math in the further procedure. So we will write P1 2 and we will transfer our first row into second and second row into first. Now it will be 1 0 0 0 1 0 1 2 1 2 and rest will be same. 2 1 2 1 5 1 2 4 3 6. Now let's get our identity matrix, or which will be a 4x4 identity matrix. Here our this part will remain same, P1 2. Now let's write our identity matrix, 4x4 identity matrix: 1 0 0 0 0 1 0 0 0 0 1 0, and our last row will be 0 0 0 1. Now we will multiply this with our given matrix, our 1 0 0 0 1 0 1 2 1 2 2 1 2 1 5, and our last row will be 1 2 4 3 6. Now as we learned before, we need to make one side a lower triangular matrix and other side will be our upper triangular matrix. We will do the same as we do in the previous one. Here we will do one our lower triangular and one will be our upper triangular. Now for this we will multiply again like how we have done in the beforehand. Let us do P1 2, our identity matrix: 1 0 0 0 0 1 0 0 0 1 0, and finally 0 0 1. As we said, we will at first we will do it for the first column. For here we will be multiplying our first row with 0 and subtract with our sorry for that, and subtract with our second row minus 0 multiplied by first row. Here I have given the 0, and now let's do the math. 1 0 0 0 1 0, these columns 1 2 1 2. Yeah, this our second row is done. Now let's move for the third row. For the third row, we will be doing with our first row will be multiplied with 2 and it will subtract with the third row. While we do this, the third row minus 2 multiplied by 1, our first row, and then we will get, as we got 2, we will give it here, and after the calculation we will get 0 1 2 1 3. And for the final row, we will be multiplying our first row with 1 and we will subtract this with our fourth row and subtracting 1 with our row 1. And as we got our final digit, we will implement it here 1, and the final row for our right hand side matrix will be 0 2 4 3 5. Now let's move forward. Our this part will be same, P1 2. Our first two rows and first two columns, our sorry for that, I am having a sore throat, so it is suffering me. Yeah, we will, our first row and second row will be same, 1 0 0 0 0 1 0 0, and our first column will be same also. Now for our this part, our column 1 and column 2 will remain same as before, 1 0 0 0 1 0 1 2 1 2. Now here comes the calculation part. For this we will multiply our second row with 1 and subtract it with our third row. Our third row, subtracting 1 for that. Does anyone have any questions? Let's continue. We're multiplying 1 with our second row. Now we will get, after the calculation part, we will get 0 0 0 0 1, and here we got 1 for our multiplication, so we will give 1 here, and for the final row we will be doing this with 2 multiplied by our second row and subtracting with our last or final row. As we got 2 here, we will put our 2 and the rest will be the same, 0 1, and after the calculation we will get 0 0 0 1 1. Now again, here comes the twist. We can't multiply 0 with this. As we can see, you can't multiply 0 to make our other numerical values 0. Now we will again change our rows. Now we will do this for our this part of the math. So for doing this, our this part will remain same. Let's write our this part, our p 1 2 1 0 0 0 0 1 0 0 2 1 1 0 and 1 2 0 1. After changing our this value, we will be changing, as I said before, we will change in rows. Now for this part, we will be changed in between our third row and in our fourth row. While doing this, we will like this, we will write p, and we will change between our third row and our fourth row. 1 0 0 0 1, and the rest of the maths will remain same. 0 1 2 1 2, and here our fourth row becomes our third row and our third row becomes our fourth row. 0 0 0 1 1, and finally our third row becomes our fourth row. 0 0 0 0 1. As we can see here, our this part has already become our upper triangular matrix, and here our this part has already become our lower triangular matrix. Now for continuing our math, we will be taking our this part in at the front, p 1 2, and then our this part p 3 4, and the rest of the elements. 1 0 0 0 0 1 0 0 2 1 1 0 1 2 0 1, and this part 1 0 0 0 1 0 1 2 1 2 0 0 0 1 1, and finally 0 0 0 0 1. Here this part is called P, or from the PLU, this part is P, or the permutation matrix P. This part is our L, or the lower triangular matrix, and here this is U, or we can see here it became a upper triangular matrix, so it is our U, or our upper triangular matrix. So from this part we can say it is PLU decomposition, or after completing this part, this after doing the whole multiplication, we will get back to our A, or the main matrix. Now if anyone have any question, you can raise your hand, or I will continue to the next part or our final part. So yeah, let's assume everyone is clear for now. Now let's get back to our slide. And in our final part, we have done our LU decomposition and we have done PLU decomposition, and I said before I will give some brief on what is QR decomposition. A QR decomposition factorizes a matrix into an orthogonal matrix and an upper triangular matrix. It aids in solving linear least squares problem and is used in various numerical algorithms. In the next sessions, we will look in the problems which is related to QR decomposition, and finally we will be doing our last two decomposition, our eigenvalue decomposition and our singular value decomposition or SVD. Yeah, this is from my side. If anyone have any questions, you can ask me. Yeah, I am giving this slide sharing here with you guys. Just give me a second. Here is the link of the slide, and if you like the session or if you know more about me, you can follow me in my social platforms. You can follow me on GitHub and you can follow me on LinkedIn. That is from my side. Thank you everyone. It was a great time with you guys. Thank you. If anyone have till now any questions, you can raise your hand and you can ask any questions. I am stopping my screen share, and now I am closing my recording.